This is homework workouts for pages 87 to 88 on limits. So I'm going to work through the problems so you can check your work and hopefully get any questions that you might have answered. So let's just jump right in. I'm looking at 5 through 31 odd. So when we find limits, we want to look at the function that we are finding the limit of, which is x to the fourth in this case, which is a continuous function. And so when we have a continuous function, we have discussed in class that the limit will equal to the y value, so we can use direct substitution. So we get 2 to the fourth. So if we were to make a graph of this function, the y value that we would be approaching as x goes to 2 from both sides is a y value of 16. So that's what I call a happy function because continuous, direct substitution. In number 7, since we have the equation of a line, so 2x minus 1 is linear, again, I can use direct substitution, and I get 2 times 0 minus 1, which is negative 1. So 2 times 0 is 0, minus 1 is negative 1. So on that line, because we know that this is a linear function, as x goes to 0, y goes to negative 1. Number 9. In number 9, we have a quadratic function, and a quadratic function graphs to be a parabola. So we have another continuous function. Sorry, my handwriting's a little sloppy here. So we have 2x squared plus 4x plus 1. So we can use direct substitution. Substitute negative 3. It is negative 3, yes, plus 4 times negative 3 plus 1, so that's 9 times 2 is 18, minus 12 plus 1. 18 minus 12 is 6, plus 1 is 7. Moving on to number 11. So we have a rational function, a variable in the denominator, and we know that division by 0 is undefined. So when we're thinking about just this function, we know in our brains that x cannot equal to 0. There's a discontinuity there. But the good news is we are not approaching that discontinuity. So the graph of 1 over x, which looks something like, whoa, it doesn't cross the x-axis. There's a horizontal asymptote there. Looks something like this. We know that graph is continuous everywhere except x equal to 0. So we can use direct substitution, meaning that as x goes towards 2, the y value we're approaching is a y value of 1/2. All right, moving on to number 11, as soon as I clear the board here. In that was number 11. In number 13, we have another rational function. So we have the limit as x approaches 1 from both sides of x minus 3 over x squared plus 4. This denominator cannot ever equal to 0. X squared plus 4 cannot equal to 0, because if you square a number, except for 0, and you get a positive number, and if you add 4, it gets more positive. So this denominator is protected. There's no discontinuity coming from the denominator, so this is a direct substitution problem. So 1 minus 3 over 1 squared, which is 1 plus 4. So that gives me negative 2 over 1 plus 4 is 5. The y value this graph is approaching is a y value of negative 2/5 if we were to look at the graph. In number 15, from the notes we said when we see radicals we think about rationalizing either the numerator or the denominator. But we don't just jump into that strategy because that's not the most fun thing mathematically one could do. And since I'm approaching a y value of 7, I think to myself, 7, what a wonderful world up that came to my head. If I substitute 7 in place of x, I don't create a discontinuity, so I can use direct substitution. And the square root of 7 plus 2, so we have 35 over 7 plus 2 is 9, and the square root of 9 is 3. So the first ones are really easy. They're just direct substitution problems. The same in number 17. I'm substituting 3 in place of x. 3 plus 1 is 4. The square root of 4 is 2. So all of these so far have been direct substitution. Moving on to number 19. I'm going to pull the screen down here just a little bit. In problem number 19, I know that sine of x is a continuous curve that just does the same thing over and over and over again. So I don't have any discontinuity, so I can use direct substitution. So the sine of pi over 2, here's my unit circle. I have 1, 0, 0, whoops, negative 1. Whoa, come on, you can do it. Negative 1, 0, 0, 1, and 0, negative 1. Sine is the y value, so the y value at pi over 2 is here, 90 degrees. The sine is 1, so that graph is approaching, like right here, a y value of 1. 21. Cosine is a continuous curve as well, so I have no breaks, gaps, or holes, so I don't have any discontinuity, so I can use direct substitution. So that would give me the cosine of 2 pi over 3. So in the first quadrant, pi over 3 is here, and its symmetrical partner in the second quadrant is here, 2 pi over 3, and if that's 60 degrees, and that's 120 degrees. So if I can remember the cosine of pi over 3 using reference angles, this would be my brain work. The cosine of pi over 3, the x value at pi over 3 is a half. But in the second quadrant, the x values are negative, so we're going to get negative 1/2. 20, where are we? 23, oh no, not secant, seriously. Secant does have some discontinuity, so I have to be careful. So let me try direct substitution first. If it'll be evident if I am approaching an asymptote. Now, you know, I know, we know, they know that secant is 1 over cosine of 2x. So I did a rewrite on that. And so now I'm going to substitute 0 in place of x, and I get 1 over cosine of 0. All right, the cosine of 0, which is the x coordinate, so back up to my unit circle, the cosine of 0, the x coordinate is 1, so I don't have 0 in the denominator, and 1 over 1 is 1. 25, they're playing with us, excuse me, on the trig right now. Sine is continuous, so I can substitute 5 pi over 6 directly. I'm going to color over here. 6 pi over 6 would be pi right here. So I'm going to back up a pi over 6, which would be right here. So the sine of 5 pi over 6 in the second quadrant, the y values are positive, is the same thing using reference angles as the sine of pi over 6. And the sine of pi over 6, which is the y value at 30 degrees, is 1/2. 27. 27, tangent does have asymptotes, so we're going to have to be careful. So I'm going to believe that I can do direct substitution until I find that I can. So I'm going to substitute 3 in place of x. The tangent of 3 pi over 4, so this is the pi over 4 family. 3 pi over 4 is in the second quadrant, so we're in the second quadrant. And we know that the pi over 4 family, the cosine of pi over 4 is root 2 over 2. The sine of pi over 4 is root 2 over 2. And tangent is sine over cosine. So we know we're going to get root 2 over root 2 over 2, which is going to equal to 1. However, in the second quadrant, the cosine values, or the x values, are negative, and the y values are positive, and a negative or a positive divided by a negative is a negative, so that's going to be our output for number 27. 29, as soon as the board clears, like right there we go. So number 29, we have e to the x is continuous by itself. Cosine of 2x is continuous by itself because e to the x looks like that. Cosine of a cosine function looks like that. So we're multiplying two continuous functions together. So I'm going to use direct substitution. I get e to the 0 times cosine of 2 times 0, direct substitution. E to the 0 is 1. the cosine of 2 times 0, which is cosine of 0, the x value at 0 is 1, and 1 times 1 is 1. 31. I have ln of 3x. I know that ln graph looks like that and is only defined for x is greater than 0, plus e to the x, which looks like that. So both of these functions are continuous on their domains. And down here I notice that x is approaching 1, so I'm not going to end up trying to take the natural log of a negative number or of 0, which is outside of the domain. So 1 is in the domain. So I can use direct substitution. The ln of 3 times 1, 3 times 1 is 3, plus e to the first power. And that's actually my answer. That is a number. That is an exact value. I don't need to pick up a calculator and do anything with it. The y value being approached is ln of 3 plus e, which is a perfectly legitimate and fine y value. Moving on to 41, 43, and 51. So in number 41, they give us a graph, and they ask us to find the limit as x is approaching 0. Now, I don't know if it's clear on in your packet. That's an open circle, but it doesn't matter because from the left and from the right, we are approaching a y value of 1. As x approaches negative 1, we are approaching from the left and from the right a y value of 3. In number 43, finding the limit as x approaches 1, which is right here, from the left, from the right, we are approaching a y value of 2. At x equal to negative 1, from the left and from the right, we are approaching a y value of 0. Interesting. So I just did 41, 43. All right, now we're coming down to 51. So in number 51, we're finding the limit as x approaches 5. That's your AP score. Nice. X minus 5 over, notice what I'm doing in the denominator because it's begging me to factor. Difference of 2 squares. Sorry, this is going sideways. The x minus 5 in the numerator divides that with the x minus 5 in the denominator. So I'm going to keep the limit as x approaches 5. 1 in the numerator, x plus 5 in the denominator. I have removed the discontinuity, so I can substitute the 5 and get 1 over 5 plus 5, which is a y value being approached of 1/10. Number 55. Oh, that's our nice rationalizing problem. So in number 55, we are finding the limit as x approaches 0 of the square root of x plus 5 minus the square root of 5 over x. Now the first thing I'm going to do, and hope and pray, is to try to substitute 0 into the function and use direct substitution. But we all know that division by 0 is undefined. I cannot substitute 0 into the denominator. So the strategy that I recommended in the video is to multiply, in this case, the numerator denominator by the conjugate of the numerator. So x plus 5, and here's where the sign changes, the one in between, plus square root of 5 over x. I'm keeping the limit because I have not found it yet. Limit as x approaches 0. So I multiply, the two radicals multiply just to give me x plus 5. I multiply, these two together, and these two together, and one of them's positive and one of them's negative, so that's that middle term that's going to subtract out and undo each other, and that's the purpose of using the conjugate. Then we're going to multiply negative root 5 by positive root 5, which is going to make a minus 5 without the radical. I didn't in the denominator. Wow, you guys aren't here to catch me. I didn't multiply the denominator by the conjugate. So I'm glad I caught that. Numerator and denominator, because remember, we're just simply multiplying by the number 1. In the denominator, I'm not going to try to multiply that x through. I'm just going to keep it in parentheses like that because I want that x to divide out. That's my whole goal, is to remove the discontinuity. I can see in the numerator the 5 minus the 5 undo each other. Let me make some more room down here. Whoops, too much. And so that leaves me with, I still keep the limit because I haven't found it yet, x over, and in the denominator I have the square root of x plus 5 plus the square root of 5. I'm going to substitute 0. Oh, wait, no, I got too excited. It's actually pretty late right now, guys, and I'm kind of tired. No excuses, classroom. So x plus 5, and then I forgot this x right here. So there's still an x in the denominator. The x in the denominator and numerator divide out. I'm keeping the limit because I haven't found it yet as x approaches 0 of 1 over square root of x plus 5 plus the square root of 5. So now the discontinuity is removed, and I can substitute 0 in place of x, which gives me 1 over square root 5 plus square root 5. So that's 1 square root 5 plus 1 square root 5 to make 2 square roots of 5. Don't try to add those two 5s together. It's 1 square root of 5. It's like 1 apple plus 1 apple. And I think we have one more problem, and I can call it a day. So let's clear these annotations, and let's do that last problem, number 63. 63 is a wonderful problem. It's just simply doing a lot of algebra. So delta x is approaching 0, and I know that I cannot substitute because division by 0 is undefined. So I'm going to follow the algebra of the problem. And so the first term tells me to square this binomial. And it is not x squared plus delta x squared. You have to write it twice if you don't know the shortcut method of multiplying, which I hope you do. You have to multiply that out, and you will get x squared. By the way, that was a question on Jeopardy the other night. I saw it. X squared plus 2x delta x plus delta x squared. So that takes care of the first term. The second term demands that I distribute a negative, so I get negative 2x minus, be careful, make sure you distribute the negative, 2 delta x, and then I'm going to copy the plus 1 that's in the problem right there. Then I'm going to distribute a negative to 1, 2, 3 terms. Whoa, my pen won't stop writing. Wow, we went crazy. It does not want me to end my day, clearly. Come on, you can do it. Come on. All right, let's try it again. Evidently it can't do it. All right, hopefully we'll make it through this video. Oh, no. I might have to stop here, guys, because I can't get my... There we go. Nope, I can't get this thing to do what it needs to do. So I'm going to stop the video here, and you can ask me about it in class. Sorry about the inconvenience. This is probably the one that you wanted to see.